All right, so curved beams. Before we go to curved beams, I'm going to do a very short introduction. This is very basic to understanding everything and to keep you up with whatever it is that we are doing. So then we have what we call the neutral axis, and then we have the centroidal axis. Okay, the difference between them is that when we see neutral, what we see a particular position within a beam is neutral. It's saying that within that particular portion of the beam. So let's see the NA, the one in violet here. If we see that position within the beam, so there's a beam like just a prismatic beam, just a straight beam, right? If we see that particular point is a neutral axis, we are just trying to see that for a particular force system or particular loading system, that particular position within the beam experiences no stress at all, right? The forces, the loading applied to the beam has no effect at that particular position within the beam. That's what we mean by the neutral axis. Okay, but then the centroidal axis is just saying that per the coordinate system, that is the center of the beam, right? So when it comes to just this straight beam, when we see the centroidal axis, just because this one is a rectangular section, right? A rectangular beam, as you said, this point here is the centroidal axis with respect to the coordinate system given, right? And then for the beam, just a straight beam, one thing that's very common is that the neutral axis and then the central axis are the same, but in this case I just wanted us to see the difference. That's why I separated them a bit. But in a beam, in a prismatic beam, that's a straight beam, we assume that they are the same and they are in the same line. Okay, yeah, that's it for them. But when it comes to the curved beam, they are not the same, almost all the time not the same. So that's why I brought a wide space between them, the central axis and the neutral axis. This is just a scheme, not the exact thing. This is just a diagram to make us understand what's actually happened within a beam and a curved beam. Okay, so what they're saying is that when you look at the cross section of these ones, whether a straight beam or a curved beam, right, the neutral axis is the point where there will be no experiences of the loading applied to the beam, right? And then when you look at the coordinate system, especially for the curved beam, the centroidal axis and the neutral axis will not coincide. Are we okay? And then because it's a curved beam and there's a curvature, we see that there's definitely a center of curvature. So it could be anywhere, but definitely because there's a curve. So let's say it's about here. So it will be something like this. If there's a curve here, meaning that there's a center of curvature, right? Meaning with that center, with a particular radius, you can draw these beams because they are kind of like concentric, right? Yes, that's why we see the center of curvature. And then if you want to actually check what's happening within every section of the beam, we actually study the stresses within every section of the beam. So if I take, let's say, this straight beam here, for instance, and I pick a particular position within the beam, right, I should be able to determine the stress there. The same for the curved beam, right? And then we know stress, the very general formula, we know it to be what? Stress to be force per unit area. But at times it's not a direct force, it's a moment, right? So what happens is that for this straight beam, this one up here, this one, the equation for describing that is moment, right? And then a y. And this y here is just trying to tell us the position from the what do you call it, the central, because you're talking about the straight beam. Yeah, the position from the centroidal or the neutral axis, that's the y. And then we have the I, which is a sectional property, right? But when it comes to the curved beam, there's a slight difference. Are you okay? So meaning that the stress can be expressed in this way or in this way, right? Okay. Then again, when it comes to this one, the stress is the same thing, but because we have a curvature, we have to the what do you call it? The stress at every curvature, at every point within the beam. So like at this particular curvature, to be different, curvature different, curvature different, and all this, it depends on the radius, right? So like as I was saying, if we have a curvature, meaning there's a center of curvature, right? So if this one here is a particular radius, if I pick another, this outer one here, if I pick another point within the beam, it will be of another radius, right? So that's why for the curved beams, we use the center of curvature right? And then we have some radius things within the equation. Right? So it's the same thing, but the stress is defined slightly different, but the same understanding. So we move on. So for this particular one, the equation is similar but quite a bit different. So you have moment, right? The moment applied, and then the y, right? And then we have the cross-sectional area, right? And then we have this E here, what we call eccentricity. It's basically saying the distance. So if I am trying to pick a particular position within the beam, let's say about here, it will have a particular distance from the center of curvature to that particular one, right? So if I have this beam here, right, this E here is just the center of eccentricity. So if I pick this section here, the very center of this beam here will be in a particular position, right? So from the center of curvature to that particular center is this eccentricity, right? But the radius, this R here, is just saying where you want to check the stress there. So that's for this particular R. Okay. So now we know the basics. We move on. Let's see. Okay. So this is a basic thing, but then I'm going to draw something else again. So let's say we have now we are done with the understanding. We are done with the straight beam. Now we're going to go all out on the curved beam. Okay, so let's see. So in the curved beam, one thing that we notice is that we're talking about some radiuses, and the center of curvature, right? Radius, and some centers of curvature. So let's say we have our center of curvature here, right? So this, if I am moving to, okay, let's name these guys again. This is the neutral axis, and the one in blue is the centroidal axis with respect to the geometry or the shape of the beam, right? Centroidal axis, right? Okay. And all these ones have names. So from the center of curvature to the very center, which is the CA, right? This one we call the RC, right? The radius of curvature, right? And then to the neutral axis we call RN. This right here we call RN. And then this is the first, if this is the beam, the one in red is the beam, right? The very first fiber of the beam that emits, or the first part that emits, we say the inner fiber, right? The one emits first. So for that particular one, this one here, we call it Rn, right? We call that Rn. This one here is Rn. So that's not Rn, that's Ro. Ri, right? The fiber that we meet first, that's the inner fiber of the whole beam, right? And then the one, the outermost, the one we meet very last is the outer fiber, which is from the center of curvature to about here, right? And this we call the Ro. They are just terminologies to make our understanding easy. Okay, so this we call the Ro, right? Okay, so this one to the center of the beam, this one the neutral axis, this is the central axis, this to the outer part of the beam, this to the inner part of the beam, the one in mid first. Okay, and then there are times where within a particular part of the beam we have indirect and direct forces, right? So if I have something of this sort, let's see, for this particular beam, if I have this here, I apply a moment or bending moment on it, right? And I pick a particular position, let's say about here, to see what's happening. Because I have no force, the only stress that we apply within this particular section will be as a result of the moment, right? And for that we write it in a particular way for the curved beam, right? Which we write this way. So the stress at a particular position is equal to minus m, right? And then we have in bracket the neutral axis minus r, right? All on r a. I'll explain all these terms later. And then we have r c Now we have Rn. Okay, the Rn, we've set the neutral radius, right? R is where we want to check the stress, right? That's the R here again. The A is the area, the M is the moment applied, right? RC is the radius of curvature, right? And the Rn is just the same thing. The radius, right? That's the distance from the point of curvature to the neutral axis, right? This is the equation. This is when we have no direct force acting on the beam, right? But if it happens that we have a direct force acting on the beam, which we'll see an example later, it becomes an additional something, right? So it will be this stress due to the moment, if there's a force causing the moment or there's direct moment, plus the force that's acting directly on that place, right, on that particular position of the beam. So it will be a plus, because stress, we have a force per unit area, right? So if this minus here is very important. If there is no direct force acting on it, we use only this with the minus. But if there is a direct force acting on it, we add this one, right? Okay, that's for the bending stress equation within a curved beam. Okay, all right. So we are going to look at some examples.